Hello students, today we are going to study some MCQs from ionic equilibrium. So first of all, here the question: to which of the following Oersted dilution law is applicable? Oersted dilution law कुनको लागि applicable हुन्छ? Here is CH3COH, acetic acid, HCl, hydrochloric acid, H3SO4, sulfuric acid, and HNO3, nitric acid. Among these, CH3COH is a weak acid. This is weak acid. Yes, weak acid acts as a weak electrolyte. It acts as a weak electrolyte, and we know that Oersted dilution law is only applicable for weak electrolyte. Whereas HCl, H2SO4 and HNO3 are a strong acid and act as a strong electrolyte. So the right answer is A. Question number 2. Which of the following Oersted dilution law is applicable? Similar question. NH4OH, it is a base, ammonium hydroxide. NaOH is also base, it is a strong base. We know that NH4OH is a weak base. This is a weak base. This one is strong, this one is also strong, and this one is also lithium hydroxide is also a strong base. So strong base act as a strong electrolyte and weak base act as a weak electrolyte. So the right answer is NH4OH. Next question. The hydrogen ion concentration in weak acid of dissociation constant. We have given here dissociation constant K and concentration is C. And we have to calculate H plus equals to what? And here option is A, B, C and D. So which one is the right answer? Which one is the right answer? Let us suppose a weak acid CH3COOH which acts as a weak electrolyte dissociate into CH3COO minus plus H plus. Here the concentration of H plus is here C, initial state ma C, and in here is CH3CO minus as 0 and H plus as 0. At equilibrium condition, certain times we get C minus C alpha, then the concentration of CH3CO minus acetate ion is C alpha and H plus ion is C alpha. Therefore, we know that H plus means C alpha. H plus means C alpha. There is no any option for C alpha. So we are converting it into another form C into, we know that alpha for Oersted dilution law, degree of dissociation for alpha weak electrolyte alpha equals to under Ka by C. For acid we can write Ka. So alpha here is Ka by C. Ka divided by C. Then we can write this equation like this, Ka into C. Yes, so the right answer is D. So H plus here is root under Ka into C. Next question. The acid with maximum strength has pKa value. pKa value, the strength of acid. Ionization constant for acid is Ka, and ionization constant in term of if the ionization constant, if we know the K, then we can calculate the pKa equals to minus log Ka. Yes, like this you can calculate, and higher the value of K, lower will be the value of pK. Like similar as pH, we know that pH equals to minus log H plus. Higher the concentration of H plus, lower the value of pH. So for acid, pK value is smaller. Yes, lower the value of pK, stronger is the acid, and higher the value of K, it means acid is strong. It means among these the acid strength maximum in 1 pKa. If the pK is 1.0, then the concentration of K is higher. It means it acts as a strong acid. Next question we have here. If ionic product of water is 10 to the power minus 14, we know the ionic product of water Kw equals to 10 to the power minus 14. what is H plus ion concentration of 0.1 molar NaOH? So we have to calculate the H plus ion concentration in 0.1 molar NaOH. First of all, we have to calculate the OH minus concentration from this NaOH. We know that NaOH dissociate completely into Na plus and OH minus. And here the concentration of NaOH is 0.1 molar and the concentration of OH minus is also 0.1 molar. It means the concentration of OH minus is 10 to the power minus 1 molar. For this, we know that H plus into OH minus, this is the ionic product of water, and it is equal to 10 to the power minus 40. And here is H plus, we have to calculate here H plus and OH minus, we know the OH minus 10 to the power minus 14 and OH minus concentration is 10 to the power minus 1. So 10 to the power minus 1 will get here 10 to the power plus 1. Therefore, the concentration of H plus is what? 10 to the power minus 13 m. Okay. So the right answer is what? 10 to the power minus 13 m. Next question. At 80 degrees Celsius, pure distilled water. Pure distilled water means pH 7. It is neutral. H3O plus concentration equal to 10 to the power minus 6. We know the concentration of H3O plus is 10 to the power minus 6 mole per liter means molarity. Okay. The value of Kw, we have to calculate the value of Kw. Kw means H plus into OH minus. Pure distilled water is a neutral. Pure distilled water is a neutral. Therefore, in pure distilled water there is equal concentration of H plus and OH minus. So we can say that the concentration of OH minus also here. Concentration of H plus is 10 to the power minus 6 and also the concentration of OH minus is 10 to the power minus 6. Then we will get 10 to the power minus 12. Yes, the right answer. Ionic product of water for this is 10 to the power minus 12. So the right answer is D. Next question. If a 0.1 molar solution of HCN, we have given the concentration of HCN here. The concentration of HCN equals to 0.1 molar and 0.01% ionized. It means degree of dissociation alpha equals to 0.01%. Then we can say 0.01 divided by 100. It means 10 to the power minus 4. 10 to the power minus 4. Okay. The ionization of HCN is, we have to calculate the ionization of HCN. Ka equals to what for HCN. Okay. According to Astra dilution, alpha equals to what? Root under Ka divided by C. We know the value of alpha, that is 10 to the power minus 4 and root under K divided by C is 0.1 molar. So squaring on both sides will get 10 to the power minus 8 equals to Ka divided by 10 to the power minus 1. Therefore, Ka equals to what? 10 to the power minus 9. Therefore, the ionization for HCN, ionization constant for HCN is 10 to the power minus 9. This is the right answer. Let us see another question. Number of H plus ion present in 250 ml of lemon juice of pH equals to 3. So we have option here. You can see the option. Lemon juice has pH equals to 3. It means we can calculate the concentration of H plus. pH equals to 3. It means the concentration of H plus shift log, anti-log, anti-log, anti-log power minus 3, then we will get 10 to the power minus 3. This is the concentration for H plus, and this is also concentration for acid. And we know the molarity is number of moles divided by volume in liter, and if we want to calculate the number of moles here, number of moles means molarity, that is 10 to the power minus 3, and volume in liter we have given here 250 ml. So you have to calculate the concentration of H plus ion in 250 ml. So 250 divided by volume in liter, that is this is in ml, so divided by 1000. Okay, and this is the number of moles. We have to calculate the number of H plus ion. If we multiply this value with Avogadro's number 6.023 10 to the power 23, then we will get the right answer here. So I am going to calculate it. 10 to the power minus 3 10 to the power minus 3 into 250 divided by 1000 and into 6.023 into 10 to the power 23, then we will get 1.506 into 10 to the power 20, 10 to the power 20. So the right answer is 1.506 10 to the power 20. So this is the right answer. Let us see another question. Question number 9. The concentration of H plus and concentration of OH minus of 0.1 molar aqueous solution of 2% ionides. Here the concentration, total concentration in aqueous solution C equals to 0.1 molar and alpha equals to 2%. It means we can say alpha equals to 2 divided by 100, then we will get 0.02, the value of alpha. Then ionic product of Kw, ionic product of water Kw equals to 10 to the power minus 14. Now we can know that H plus equals to C alpha. We know the value of C, that is 0.1, and we know the value of alpha, that is a 0.02. So the value of H plus is 2 into 1, 2, 3, 10 to the power minus 3. This is the concentration for H plus. Then we can calculate H plus into OH minus means 10 to the power minus 14. Yes, minus 14. So H plus here is 2 into 10 to the power minus 3. Then we can calculate it OH minus, that is 10 to the power minus which will be the right answer. For H plus 2 into 10 to the power minus 3, this is the H plus. Yes, this is the H plus. So OH minus will be 5 into 10 to the power minus 2. When we calculate, when we multiply this H plus and OH minus, we will get 10 to the power minus 14. Yes, minus 12, minus 3, minus 15. So the right answer is C. Yes. So let's see another question. The values of dissociation constant of some acids at 25 degrees Celsius are given below. Indicate which is the strongest acid. The values of dissociation constant we have given here. Dissociation constant, that is Ka. K value is given. This is all. These values are all K values. Yes. So indicate which is the strongest acid. We already said that higher the K value, higher the value of K, stronger will be acidic strength. Yes, it means lower the pK value. So we have given here K value. So among these, which one is highest? 10 to the power minus 2. Yes, 10 to the power minus 2 is the highest value. So the right answer is 1.4 into 10 to the power minus 2. Next question, degree of dissociation. Degree of dissociation of 0.1 normality CH3COS is 1 into 10 to the power minus 5. Okay, so we have to calculate what here? Degree of dissociation. Degree of dissociation we have to calculate here. The alpha equals to what? 0.1 normality, this is the concentration, and K is also given. So we know that according to Astro's dilution law, alpha equals to what? Root under K by C. And here alpha equals to root under K is 10 to the power minus 5, and the concentration of CH3COH is 0.1 normality, and we have to convert the normality into molarity in terms of molar concentration. We have to calculate the alpha here. So 0.1 normality CH3COS means 0.1 molar CH3COS, because CH3COS is a mono, it is a mono basic acid. Yes, so normality equals to m into n. So n is 1 for this mono basic acid. Therefore the value of C is 10 to the power minus 1. Then alpha equals to under 10 to the power minus 4. It means alpha equals to 10 to the power minus 2. So which one is right answer? So A is the right answer. The right answer of 11 is A. Next question. If 0.1 molar of weak monobasic, we know that weak monobasic, it means the normality and molarity is same, is taken, and its percentage degree of ionization. Degree of ionization alpha equals to 1.34%. So we can divide by 100, then we will get 1.34 into 10 to the power minus 2. This is the degree of dissociation. Then calculate its ionization constant. We know the ionization constant Ka. This is monobasic acid, so it is acid, so we can calculate the Ka, and the concentration is 0.1 molar. Yes, and here is answer. 0.8 into 10 to the power minus 5, 1.79 into 10 to the power minus 5, 0.182 into 10 to the power minus 5, 5 into 10 to the power minus 3. So we can calculate the ionization constant Ka. According to Astro's dilution law, alpha equals to root under Ka by C. Then here alpha is 1.34 into 10 to the power minus 2, and we have to calculate Ka, and the concentration is 0.1. So squaring on both sides, square got the root. Therefore Ka equals to, so you can calculate 1.34 into 10 to the power minus 2 square into 0.1. So you can calculate this. 1.34 into 10 to the power minus 10 to the power minus 2 square 1.34 into 10 to the power minus 2 power 2 into 0.1. Then we'll get 1.7956 into 10 to the power minus 5. 1.79 10 to the power minus 5. So this one is a right answer. Okay, so then we'll get here 1.79 into 10 to the power minus 5. Question number 13. Here Ha is a weak acid. Ha is a weak acid. We know that weak acid Ha dissociate into H plus and A minus. The pH of 0.1 molar acid Ha solution is 2. pH equals to 2. It means the concentration of H plus, we can calculate, concentration of H plus is 10 to the power minus 2 molarity. Okay, what is the degree of dissociation of Ha? We have to calculate alpha equals to what? Alpha equals to what? According to Astro's dilution law, we can use the relation alpha equals to under Ka by C. but we don't know here Ka value. Yes, we don't know the Ka value, but degree of dissociation, yes, degree of dissociation we have to calculate. So for degree of dissociation, alpha equals to what? So we know that H plus is H plus, when we dissociate it, we know that H plus is C alpha, A minus is C alpha at certain time. So at equilibrium condition, so H plus equals to C alpha. We know the value of H plus, that is 10 to the power minus 2, and the concentration is 10 to the power minus 1, that is given in equation. Okay, and we have to calculate alpha. Therefore alpha equals to 10 to the power minus 1, that is 0.1. So the right answer is D. Let's see another question. Highest pH 14 is given by, highest pH 14. So pH 14 means it should be a strong base. It should be a strong base. Higher the pH, weaker the acid. Okay, so here is, we have this acid, and this acid is eliminated already, and NaOH and NaOH both have concentration. One NaOH has 0.1 molarity and another is 1 normality. It means 1 molarity NaOH, this is the high concentration, than 0.1 molarity NaOH. So you can say that the pH of NaOH, 1 molar NaOH is nearly equal to 14. So the right answer is C. That is 1 normality NaOH. This is wrong answer. The pH value, maybe for this we can calculate pH value. OH concentration is 10 to the power minus 1, then H plus concentration is 10 to the power minus 13, and pH equals to 13. Yes. Similarly for 1 molar NaOH, OH concentration of OH minus equals to 1 means 10 to the power minus 0. Yes, so H plus into OH minus equals to 10 to the power minus 14, then we will get H plus equals to 10 to the power minus 14, minus 14 here. So we'll get a pH here 14, or we can direct calculate here POH. When we know the concentration of OH minus, then we can calculate POH minus log OH minus, that is 1, that means 0. So we can say pH equals to 14. So total pH equals to 14. So the right answer is C. Next question. Calculate the pH of solution in which H plus is 0.005 gram equivalent for liter. So we have to calculate the constant pH equals to what? Yes, for this we should know the concentration of H plus equals to what. So we know the concentration H plus is C alpha. So we have option here. The concentration of H plus equals to 0.005 gram equivalent per liter. Gram equivalent per liter. So gram equivalent per liter. Therefore, the pH will be minus log H plus, minus log H plus. So we know the value of H plus minus log 0.005. Then we will get minus log 0.005, and the answer is 2.30. 2.30. The answer is 2.30. Right answer is B. Let us see another question. An aqueous solution whose pH equals to 0. As for acid, yes, strong acid has pH 0. Strong acid has pH 0. Acidic, basic, neutral, amphoteric. So the right answer is acidic. pH equals to 0 means it is a strong acid, high concentration. Okay, so right answer is acidic. The next question. The hydrogen ion concentration in mole per liter per decimeter cube, that is mole per liter, in 0.2 molar. The concentration is 0.2 molar, and the hydrogen concentration we don't know, H plus. Okay, and weak acid, it is a weak acid, HA, and we have given Ka, that is 2 into 10 to the power minus 5. So we have to calculate the H plus. We have to calculate H plus. You know that HA dissociate into H plus and A minus. When HA at initial concentration C and the concentration of H plus and A minus is 0, after a certain time or at equilibrium condition, the concentration of HA will be decreased like C alpha, concentration degree of dissociation alpha, then we'll get the concentration of H plus is C alpha and concentration of A minus is C alpha. Okay. Now we have to calculate the concentration, hydrogen ion concentration, that is a C alpha. We know the value of C, but we don't know the value of alpha. So we have to calculate alpha by using Oersted dilution law. Alpha equals to root under Ka by C. Root under Ka by C, where Ka is 2 into 10 to the power minus 5 and C is 0.2. Then we'll get the value here, root under 2 into 10 to the power minus 5 divided by 0.2 divided by 0.2, then we'll get here 10 to the power minus 1 divided by 100, that is 10 to the power minus 2. This is the value of alpha. So we have to calculate the H plus, that is a C alpha. So H plus equals to C alpha. C alpha, here concentration is 0.2 and the alpha, value of alpha is 10 to the power minus 2. So the right answer is 2 into 10 to the power minus 3. The right answer is 2 into 10 to the power minus 3. Okay. 2 into 10 to the power minus 3. So let us see another question. Equal volume of 3 acids. We have 3 acids, pH 3, 4 and 5. Are mixed in vessels. What will be the H plus ion concentration in the mixture? So it is a very easy question. So we have given pH 3, 4 and 5. It means the concentration of H plus, we can directly say 10 to the power minus 3 for one acid, for another 10 to the power minus 4, for another 10 to the power minus 5. This is the concentration of H plus. So we have to calculate what will be the H plus ion concentration in mixture. So we have to add these 3 concentration of H plus and we can calculate the average, that is divided by 3. There is 3 acid, so we have to divide by 3. Now we can calculate 10 to the power minus 3. We can take common 10 to the power minus 3. Here we can calculate 10 to the power minus 3 plus 10 to the power minus 4 plus 10 to the power minus 5 and divided by 3, and the answer is 3.7 into 10 to the power minus 4. 3.7 into 10 to the power minus 4. Yes, 10 to the power minus 4. Which one is the right answer? B is the right answer. So you have to calculate the total concentration of H plus. Here all 3 acids have pH given. Then we can calculate the H plus. Total concentration we can calculate by the average concentration by dividing by 3. Okay. Next question, question number 19. The number of hydrogen ion in 1 ml solution of pH 13 is. So you have to calculate the concentration of number of hydrogen ion. First of all, we have to calculate the number of moles of H plus ion and pH equals to 13. Here pH is given 13. And H plus concentration, we can say that pH equals to 13. It means the H plus concentration is 10 to the power minus 13. Okay. And Molarity, we know the molarity. Molarity means number of moles divided by volume in liter. Volume in liter. So you have to calculate first of all number of moles. Number of moles equals to molarity, that is the concentration of H plus 10 to the power minus 13 into volume in liter. Volume in liter we have given 1 ml, so 1 ml divided by 1000. Therefore number of moles equals to 10 to the power minus 13 into 10 to the power minus 3. Then 10 to the power minus 13 and minus 3, that is minus 16. This is the number of moles. So we have to calculate, this is the number of moles of hydrogen ion, H plus ion. And we have to calculate number of hydrogen ion. Therefore, a number of hydrogen ion is equals to 10 to the power minus 16 into 6.023 10 to the power 23. That is Avogadro's number. Then we will get 10 to the power minus 16, 10 to the power 23. It will get 10 to the power 7. Then 6.023. So the right answer is 10 to the power 7. See, this is the right answer. 6.023 into 10 to the power 7. This is the right answer. So next question here. The dissociation constant of CH3COOH is 1.6 into 10 to the power minus 5. Dissociation constant Ka equals to 1.6 into 10 to the power minus 5. Okay. The degree of dissociation of 0.01 molar CH3COOH. Here's concentration of CH3COOH is 0.001 molar. Presence in 0.1 molar HCl. Therefore, there is a CH3COOH which is weak acid and another acid is a strong acid. So we can see the common ion effect here. HCl dissociate into H plus and Cl minus. The concentration of H plus here is 0.1. The concentration of Cl minus is also 0.1 molar. Similarly, weak acid dissociate into CH3, COO minus and H plus. Okay. Then the concentration of CH3COOH is 0.01, and it dissociate into its ion, like we can say that this is the concentration. Okay, I am taking here. Concentration of H plus will be C alpha and CH3CO minus is also C alpha. Here the concentration of H plus should be added in this term because H plus total concentration will be increased in the solution. So we have to add the 0.01. This is the total concentration of H plus. Okay. Now ionization constant Ka. Ionization constant K equals to the concentration of product, that is C alpha into C alpha plus 0.1, yes, divided by CH3COOH. Then we can say that here is C according to Astra dilution law, C minus C alpha. The concentration of reactant is decreased by C alpha, so we can divide by C alpha. So we can calculate here by putting the value of C. We know the value of C, yes. Here we can C minus C alpha here. C minus C alpha. We can take the common here. C alpha into C alpha plus 0.1 divided by C1 minus alpha. Okay. So and then we can cut this C and C. Okay. Now putting the value of alpha, putting the value of K here, sorry, value of K will be, that is given in the question. K is 1.6 into 10 to the power minus 5, and alpha we have to calculate alpha. Here is also C alpha plus 0.1. So we can 0.1 concentration is very high concentration, so we can neglect this term also. 0.1 divided by 1 minus alpha. Alpha is very small value, so we can neglect that. 1 minus alpha is nearly equal to 1. Therefore the value will be, so alpha equals to 1.6 into 10 to the power minus 5 divided by 0.1. Then alpha equals to 10 to the power 1.6 into 10 to the power minus 4. Then we can say which one is the right answer. Which one is the right answer? Then we will say that alpha equals to 0.0016. So which one is the right answer? So there is no any right answer. I think we have written the concentration of CH3COS 0.01. Yes, so we are writing here 0.1 here, 0.01, and here is the concentration of C is cancelled here 0. So we have done some simple mistake here. 0.01 the concentration of CH3COS. So we can multiply by 0.10 to the power minus 2, then we'll get 1.6 into 10 to the power minus 3 here, right? 1.6 into 10 to the power minus 3, then we'll get 0.016. So the right answer is A. Okay.